Okay, so here you can see the prototype setup of the mechanical ventilator. Here on the left side, we have a air compressor that is working to simulate the supplied pipeline pressure from a hospital pipeline. We can regulate that anywhere we want. Right now, the regulator is sitting at around 10, just a little bit under 10 psi-G. The pressure on the other side is right around a little bit below 100, 100 and something psi-G. That goes into some tubing, which then comes up here to our flow path section. So we have 3 separate flow paths that are controlled by V1. That's valve 1, valve 2, and valve 3. Nominally, each one of these should have a small orifice of a different size directly downstream of that valve. That would be able to independently control the flow rate when you open up that valve with that orifice. They then manifold back together into one section here, where there's then a T that goes off to our relief valve. We'll get to that in a second. And then the other side comes into our lung simulator. The lung simulator, obviously this is just a balloon that's attached here. Then on the other side, so that's the entire inspiratory leg. Then we have the expiratory leg of the device here, where we have V4 that's serving as the exhaust valve. So now let's take a look here, and we can take a look at the 2 pressure controllers that we have. So you can see this one is labeled PEEP, and this one is labeled plateau pressure. So the one labeled plateau pressure comes from the inspiratory side, and you can see that there's a water column in here, quite literally filled. Right now it looks like it's right below 29, and that's 29 centimeters of water, meaning that if you go above 29 centimeters of water pressure in any of this tubing, then that will actually bubble through here, and that will prevent you from causing barotrauma, or in our case, popping the balloon. On this other side, you see this is PEEP. So PEEP is positive end expiratory pressure, and we want to maintain a small PEEP value of, say, between 5 and 10 centimeters of water pressure in the lungs to prevent alveolar collapse. And you can see here that right now we are sitting at, sorry about that, right now we are sitting at about 5.5 or so centimeters of water in that tube. And so that's going to be the PEEP, the effective PEEP pressure that we are able to maintain. So it's important to note right now we don't have the orifices installed, so we are not super accurately able to control the flow rate other than by personally me throttling one of these valves, only opening it a small amount. So if I do that, then that will open up this entire inspiratory phase up to the balloon to the potentially up to 10 psi that we had on our gauge here, just below 10 psi. So you can see that if I start to open this valve, a few things will happen. One is the balloon will start to inflate. And then the other thing that's important to note is that we are actually seeing bubbles from the plateau pressure portion of the system. So this is good. This means that that is working as expected, and that is preventing overpressurization of the lungs. So we are not, so that means we know that this entire section is at whatever we said that pressure was at, just around 29 centimeters of water pressure. If I close this valve, then you can see the lung maintains pressure because there's nowhere for it to vent. And then the bubbling through the plateau pressure stopped, indicating that there's no flow on the inspiratory leg of this section. So now we have the expiratory leg of this section. And so again, we have the lung, which is still holding, right now we know that it's holding about 29 centimeters of water positive pressure in there. And then if I go and I open this up, it's important to watch what will happen here. You can't really see the tube in there, but remember that was at about 5.5 centimeters of water pressure. So let's see if I can do this so we can see both the bubbling and the lung deflate. Maybe if I hold it that way. Not really, my arm isn't long enough. So anyway, we'll focus just on this, and then so remember, this is what the balloon looks like now. We'll focus right here. And you can see that as I begin to open up the valve, we are bubbling through, and that was the effective expiration. And so you can see now the balloon is slightly less inflated. So now it's sitting at whatever that peak pressure is. So that around five or so PSI. And we have not PSI, 5 or so centimeters of H2O. And we have maintained that pressure in the lungs. I've now shut off all of the valves. And that is the simple example of how this mechanical ventilator works. The next step is to replace the manual valves with a set of remote valves. So that's these, and these will be installed where each of the manual valves is now, and then we'll be able to command them with correct commands from the user. Okay, let me know if there's any questions on that or how this works.